Here is an example of communications using UDP sockets. Again, we have the server on the right and the client on the left. So starting with the server, we're opening a TCP socket indicated here by sockstream. We bind the socket to our local host address and port 8080. On a normal web server, this would be port 80, but since I'm running a web server, that port is blocked from my computer. You can use 8080 or really any other port as an alternative, almost any other port. Okay, then we listen for connections. Here we're going to allow up to one simultaneous connections. Once we have a connection, we can then accept that connection. And we'll get a connection variable and the address on which we connected. At that point, you can start receiving requests on that connection, and we'll receive up to 64 bytes. We'll print out the request, and then we will send a response also to the connection, encoding it as UTF-8 as in the UDP example. Finally, we close the socket to release the ports. On the sender side, we open a socket, a stream socket as on the server. We connect to our local address, port 8080, which is the server address, and then we send a request to the socket. Okay, and then afterwards we will process the response from the server by receiving 64 bytes of it and printing out the response. Notice that on the client side, you're communicating with using the socket variable, while on the server side, you communicating using the connection. The reason is that the socket is long-lived, and there could be many connections being accepted by the different threads, potentially. And so here you have connection becomes sort of the new socket variable, whereas on the sender, you're still using the socket that you used to connect. I will make the reason for this more clear in the lectures or on the lecture slides, depending on when you are watching this video.